Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, now we are going to give the IUPAC nomenclature for the alkanes, that the structure that we have. So let us start with the nomenclatures, that how can we give the nomenclature to the particular alkane or the structure of alkane that has been provided to us. So starting with the first one, and yes, we would mention all the rules that we have followed, and we will be careful for that, and then only we are going to write the IUPAC name for the structures. So let us start with the first one that we have. So this is a structure that we have that you could see, and for this we have to give the IUPAC nomenclature. So before giving the IUPAC nomenclature, we should follow the rules that we have. And the first rule, that is the main rule that we should follow, is we have to choose the longest continuous chain of carbon atom in the structure that has been provided to us. So in this case, what I could see, that if I will choose this to be the longest chain, where it consists of 1, 2, 3 carbon atoms, even this will be the straight longest chain. Or else I could see 1, 2, 3. Again, this will be the longest chain. So in any case, I could take the branch or I could take the numbering. So therefore, in this case, suppose if I have chosen this to be the longest chain. So if this is the longest chain, then this is the first thing that we have decided. But the second thing is we have to observe the substituent also. So in this case, I am observing a substituent, that is the CH3 group. But where should the numbering start? The numbering should start from that end, or that end of the parent atom that we have decided, where the substituent group should get very less number. So in that case, if I will start the number from here, that is, if I give the number of to this carbon has to be 1, so therefore this will be the 1, second carbon atom, and third. And in second carbon atom, I could see a substituent. But what if happens if I number from left side? So again, this would be the 1. Suppose this is the 1. This will be the second, and this one will be the third carbon atom. So in this case, I could observe that again the second carbon atom, I am getting the same substituent, that is CH3. So this means that you could number it from at any point, that is from left to right or right to left, that your screen that you see on the screen. So let me do it by numbering from this section, that is from left to right. So 1, 2, 3. So in this case, basically on the second position, I could observe the group or the substituent, that is the methyl group. So how to name that? So the substituent should be named first, and then the overall parent hydrocarbon. So in the substituent that we have, it is basically the methyl group, and the methyl group is attached to the second carbon atom of the parent chain or the straight continuous chain. So in this case, the name of this would be 2 hyphen, because I'm now writing the alkyl group, so therefore 2 hyphen methyl, and the number of carbon atom that is in straight chain is basically 3 carbon atoms, and that makes to be propane. So now this is propane. But this is the rough thing that I have drawn. Why? Because the alphabet should start with the capital one, and in this case I have mentioned it with methyl. So therefore this would be a wrong thing to mention in this format. So and moreover, we could see that all the IUPAC name should be in a same word. It should be in this of a one word only. So therefore the correct method to write the name would be in this manner, that is 2 methyl propane. So this is the correct method of writing the IUPAC name. So this is the IUPAC name of the first structure that you are observing. So now this was one of the most simplest thing, and let us move to the next one that we have. So let us do that also. So this is the second structure of which we have to give the name, and yes, let us start with the first rule that we have, that is to choose the longest chain and continuous chain of carbon. So in this case, the continuous chain of hydrocarbon can be, if you choose this section, again, suppose if I choose this one, again it would contain the same that is 3 carbon atom, and if I choose the upper one, as you would see in this section, so again this would contain the same carbon atom, that is 3 carbon atoms. So let us number While numbering, again, we will see that the substituent should get the lowest number. So even though if I give the number from left to right, again, suppose if I say 1, 2. So in second position, I get the 2 substituents. And in third, it is 5. It is vacant basically. So now when it comes to left to right, right to left, so now again, this is suppose 1 and this is again, it is 2. So in second position only I am getting the substituents, and moreover what I could see, I could get 2 substituents, that is a methyl group and again a methyl group. I'm just, for an instant, I'm just rounding it so as to differentiate that our main thing is to write the parent carbon atom, and moreover the substituents in this are basically methyl groups and they are attached to the second carbon atom. So therefore the number would be 2 times that of the methane, that are methyl group that are present. So therefore to write that thing, it would be very much easy, that is 2 comma 2, because both the substituents are, or the branching starts from the second carbon atom. So therefore there are 2 branches that are been starting from that are been originating from the second carbon atom. So that's the reason 2 comma 2. And moreover we could see that these are the same methyl group, the both are the same. So therefore we would write di. Di means 2 methyl. So this is the one that we are done with the groups, and now we are moving towards the main hydrocarbon that we have in the parent chain. So the parent chain consists of basically 3 carbon atoms. Basically in terms of alkane, it is known as propane. Very simple to understand. So now this is the second one, and now let us do the third one that we have. So the main motive is to understand each kind of IUPAC so as to we should not get confused, and we would be able to write any of the IUPAC name of an alkane that has been given to us or that has been provided to us. So now this is the next one that of which we have to explain, as well as we have to write the IUPAC name of this structure. So in this case, the first thing obviously we have to do is we have to decide which one is the longest chain, and for that let us choose this manner. Suppose if I choose a straight chain, that we usually think that a straight chain will be a longest chain, but it is not necessary. So let us start with this thing. Suppose if I choose this one, that is 1, 2, 3. If this line that I have chosen, so I have got 4 carbon atoms. But is there more carbon atoms that I could get in the continuous form? So let us check that also. But if I choose this to be the longest chain, so again 1, 2, 3, 4, 5. 5 carbons are there in a continuous chain. Again I will check whether there is the longest chain or not. 1, 2, 3, 4, 5, 6. Again I got 4 when I came to this straight chain. Then I got it is to be 5, and later I got to know it is to be 6. So now this is the 6, which is the highest continuous longest chain that we have. So now what I'm going to do is I'm going to just for an instant will choose this one. Suppose if I choose this one, and so this is the longest chain that we have of carbon atom, and now we are going to decide that the numbering should start from where. This is the main thing, our main challenge that we have to do. So let us start with the ends, because numbering starts with the ends only. So therefore, suppose if I given the number to be here as 1, so this is would be 2, this would be 3. So on third I get a substituent. On fourth, yes, again I will get a substituent. And fifth, sixth. So 6 carbon atoms are there in a straight chain. So basically we are talking about an hexane. But this is what I have or I have decided to number from this corner. But what if I have decided the number from this corner? So let us check that also. This would be the first carbon, second carbon, third. Okay, again third position I am getting a substituent, and fourth, again I am getting a substituent. So in both the directions, suppose if I choose, I will get the same number of substituent, that is at carbon number 3 and carbon number 4, or the locantes are basically 3 and 4. So at anyhow I could give the number. So suppose if I write the number, or I have given the number in this way, that is 1, 2, 3, 4, 5, 6. So now the groups that are being attached is on the third and on the fourth. But what are the groups? See, this is the one that we have got to know that we have made us to know that every carbon atom, when we choose a straight chain and longest chain carbon atom, this is not necessary that they should be straight. So that's the reason I have chosen this, so as to make you know that even the straight chain or the longest chain can be of this form. And now moving back, that we have to give the number to the substituents. So the substituents are basically the methyl groups, and the both are being methyl groups, and they are attached to the third and fourth position respectively. So I could name it as 3, 3, because this indicates the locates basically. 3, 3 di means 2 times methyl group di methyl, and the total number of carbon in a straight chain is basically, or in the parent carbon that we could see, parent hydrocarbon is basically 6. So therefore it makes to be called as hexane. So therefore this is the name of 3, 3 dimethyl hexane. So now it was one of the easy one. So let us check the next one, that how can we give. So it has this kind of structure, and for which we have to give to the IUPAC name. So by looking at this, I could say that the longest chain would be this one. It is very easy to understand. But the numbering that would be started, it can be started from left corner also. But we know that we should give the number in that manner that the substituents that are being attached to the parent carbon atom or the parent hydrocarbon atom, it should be less. So the substituent should get less number. So that's the reason what I'm going to do is I'm going to number in such a way that this substituent should get the least number number. So therefore this will be the first, second, third, fourth, fifth carbon atom. And in this case, what I could see is on second and on third, I could find that the methyl groups are being attached. So therefore, what would be the name of this thing? Again, it is very simple to understand. It would be basically 2, 3, because this is comma is been used for differentiating the two numbers or the two locates. And since both the substituents are being all the substituents that are being present in this molecule is basically methyl. So therefore dimethyl, 2 methyls are being present, so therefore the name of this will be dimethyl. And the total number of carbon in a straight chain, or what we have chosen as a continuous chain or a parent hydrocarbon in this case, is found to be 5. So 5 carbon hydrocarbons are basically known as pentane. So pentane, but the hydrocarbons when if are alkane. So this is an example of alkane, that makes this to be called as a pentane. So this is the IUPAC name of this structure. So now let us move on with the next one that we have. So this is the structure that we have and to which we have to give the name. So suppose for this one, if I have to choose the longest chain, then what would be the longest chain? So this is a bit a challenging one. So how? I could choose either this one also, that is 1, 2, 3, 4, or else I could choose 1, 2, 3, 4, or else 1, 2, 3, 4. Again, in anyhow, I would consider that that would be a longest chain. I usually prefer to call it as straight chain because usually whenever we convert a, that is an IUPAC name to structure, so we usually because of the parent name of it, we write it in a straight chain and then we add the substituents. But in this case, what we are going to see, the longest continuous chain of carbon atom. So therefore, this would be this one also. This could be this one also. So now let us name. But before naming, numbering is most necessary for the substituents. So in this case, I could see, suppose if I have given the number from this side, that is from this corner. So this one would be first, second, third, and fourth. But what if we have given the number from here? So therefore, this would be the first, second, third, fourth, where I could see that on second position, the substituents are being present. So that's the reason the second position means the locant is lower. That is, we have given a lower number to the substituents, and that is how we have followed the IUPAC rule. And now let us name it. The naming of this would be very much easy because again the 2 methyls are being present in this molecule as a substituents. So therefore, I could name it as 2, 2. Again, 2 methyls are being present. So therefore, dimethyl. And this molecule contains a parent hydrocarbon called to be 4 atoms of carbon, so therefore that would name to this to be called as butane. So name of this would be 2,2 dimethyl butane. Very easy to understand. So now, just for in this case, let us practice another one that we have. So suppose in this case, suppose we have the sixth one. So for now, how could we choose the longest chain? That is the main thing. So let us choose the longest chain. Suppose we observe it in a straight forward, that is we think that it would be a straight chain. So for that I see that this is first, second, third, fourth, fifth. So fifth is the one which 5 carbons that are being present in a straight chain, or that could be a longest chain also. But is that necessary? Let us check another method. So if I choose this one to be the first, second, third, fourth, fifth, sixth, I have got a longest number, more longer than the previous one that I have calculated in this straight region. So now what I have observed is I have observed more number of carbon atoms when I have chosen this to be the longest chain, longest continuous chain. So this is the longest continuous chain, and now what we are going to do, we are going to numbering it, because the substituents are also been present in this case, and we have to give the number to this one. So how can I give the number? So the numbering will start from the substituent where the with that from that corner where the substituents will get less number. So in this case, suppose if I have given the number as 1, 2, I could get a substituent at 3. So I am writing as a rough corner as to be 3. Then this is the fourth one, and this would be the fifth one. But is there any other method where we could see that the substituents will get less number? Let us check that also. Suppose this is the first carbon atom, this is the second. I could see that at second there is a substituent, so I'll name it as second. Third also, okay, and again on fourth also I have got a substituent. And fifth and sixth, they don't have any kind of substituent attached to that. But if I observe these two numbers, I could see that this number that we have is very much smaller than the above number that we have, or when it comes to the localization. And we have also followed the rule that the substituent should get the lowest number. So in this case, basically the 2, 3, 4 are the one which are very lower than that of 3, 4, 5. So that makes the method to give the number that should be from left to above. So therefore this would be 1, 2, 3, 4, 5, 6. And this is now how we have choose the longest chain, as well as we have numbered that also. And moreover, we have to give the substituents their number along with the IUPAC name that should be mentioned in that case. So therefore this is the second, first, second and third, 3 methyl groups have been there, and on the second, third and fourth position respectively. So the name of this would be, we could write it as 2, 3, 4, and there should be hyphen. And what I observe is I observe 3 times methyl groups that have been observed as a substituent in this parent hydrocarbon. So therefore for name that would be trimethyl. And the total number of carbon in a straight chain or in the longest chain that we know is basically to be called as a parent hydrocarbon is 6, known as hexane. So this is the name of this structure. Very easy to understand. So now let us do with the 7th one also. So now this is the structure that we have, and we have to give the IUPAC name of to this one. So let us choose that which one would be the continuous longest chain of the carbon atoms. So if I choose 1, 2, 3, 4, 5, this would be 5. But what if I choose 1, 2, 3, 4, 5, 6? I've got 6 carbon atoms. So therefore when I have chosen this to be the longest chain. So now let us number it. So if I number it, so the thing is we have to give the number in such a manner that the substituents should get less number, and where the substituent where we observe should be more. So in this case, basically, since this is the longest chain and there is no other chain that we could see where we could find 6 carbon atoms, so therefore let us give the number to this one. So I'll start the number from here because I could see that this substituent, that is CH3, it has been very close to the number that from where I have started. And if I started the number from here, so therefore this is the first, second and third. So third is the number where the substituent starts to be attached in a branch manner when I start from here. So therefore I have to start the number from here. So therefore this will be 1, 2, 3, 4, 5, 6. So where are the substituents located at? They are located at position number 2, 3, again 3 and 4. So let us name it. It is very much easy to understand. That is on second, on third, and again on third, as we could observe, and on fourth the substituents are being attached, and those substituents are nothing but they are methyl groups. And how many methyl groups have been there? 1, 2, 3, 4. 4 methyl groups are there. So therefore we'll name it as 2, 3, 3, 4 tetra methyl, and the total number of carbon in straight chain is 6, or basically we could say that the parent hydrocarbon is 6, making that to be known as hexane. So this is the IUPAC name of this structure. Now we are going to do the another one, that is for the 8th structure that we have, and we have to give the IUPAC name to this structural formula. But let us understand that which one would be the longest chain, because the first thing that we are going to do, we are going to choose the longest chain, and that should also be the continuous one. So now in this case, if I choose from this carbon, so this would be the first, second, third, fourth, fifth and sixth. So if I move in a straight way, that is from left to right, without any corner, or if I don't bend, suppose if I'm going straight from this direction, that is from left to right, and I see that the total number of carbon that are continuous are basically 6. But what if I take a turn towards here, or I will take a turn on this branch? So let us see that how much carbon atom does it has. 1, 2, 3, 4, 5, 6, 7. So this 7 indicates that this is the longest continuous carbon chain that we have, not this straight line that we have supposed that it would be. So therefore what we are going to do, we'll mark this thing to be the continuous chain, and this is what we have got, the 7 carbon atoms that are present in a continuous form, and when it comes to in concern with the IUPAC. So now the first thing is done, and now there are substituents, as we could see, because there are many substituents like CH3, CH3, C2, CH2, CH3 and CH3. That is methyl group as well as ethyl groups are being present in this chain. So now we'll number it from where? We'll number it from this corner or this corner, that depends. And that depends on the number of substituents that we get more from the side. That means, suppose if I number it from here, so therefore this one would be the first carbon, second carbon, and this one would be the third carbon. So therefore I get a substituent at number 3, that is the locate number of that substituent is 3. Then 4, then 5, again I am getting a branch at 5. Then 6, again 6, because I am getting another branch or another substituent over the 6th position. But is this the correct method to give the numbering, that if I have started from this corner and I am moving towards this corner? Let us go for the another end and let us check whether what kind of the number that we are getting. So suppose if I consider this as the first carbon, this one would be the second. Again there is another substituent or another group that is been attached to the second carbon atom. Then I'll move towards the third, and yes, I could see that there is another substituent, so I could write it as 3, then 4, then 5, and I could see that at 5th position also I could see the substituent that has been attached on the 5th carbon atom of the parent hydrocarbon according to the IUPAC. So now, we'll choose which one, the earlier one that we have to, or the last one that we have to, or we have made that it would be the correct IUPAC indication for the substituents? The correct one is this. The reason behind, because we have studied this in IUPAC nomenclature, that is the rules of IUPAC nomenclature, and in which we have got to know that we'll start the numbering from that, and that will contain more number of substituents, and moreover, if we see that the number of substituents should be very much close to the end that we start. So now that, suppose if I've started from this corner, so I'll name it as 1, 2. So in second position only, or in the second carbon only, I could see the branch or the substituents. Meanwhile, if I observe this one, so I have got the substituent at number 3. So now, therefore we will move further. So therefore this one would be the third one, this one would be the 4th, 5th, 6th and 7th. And let us write and let us understand that which groups are present. That is, when I consider the CH3 group, that is known as methyl group. So methyl group is present at second position. Again, I could see that the methyl group is present on the second position, and I could see that the methyl group is present in the 5th position also. So therefore there are 3 methyl groups that are present in this structural formula. So when it comes to the IUPAC naming, and what I could see is, I could also see C2, CH2, CH3. Basically this is nothing but ethyl, while the others are basically methyl. So the naming will be as per the IUPAC rules, and the IUPAC rule says that we should give the numbering, and the numbering is been done, but the naming, it should be done in an alphabetical order. So therefore, since ethyl starts with E, alphabet E, and methyl starts with M, so that makes us to write the ethyl group first, and then we'll start with the methyl one. So therefore the IUPAC name of this one would be very much simple, and that is, for ethyl we will write the substituents first, and then we'll move on towards the parent's carbon atom, that it contains 7 carbon atoms, and it is an alkane. So let us start with the first one, that is, since this is the ethyl group that has been attached to the 3rd carbon atom, so the name of this would be 3-ethyl. And once this is been done, and let us see that what else are the substituents that are in this parent hydrocarbon or this continuous chain, that is CH3, 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 and this all 3 are been attached to, that is second, again second, that is the 2nd carbon atom, and talking about the next one, that is 5th. So 2, 2, 5, and how many number of methyl groups are there? 3. So therefore we could write it as trimethyl, and the total number of carbon in a continuous straight chain is basically 7. So for 7, an alkane that contains 7 carbon atoms are basically known as heptane. So now this is nothing but heptane. So this is how we write the IUPAC name. So that's the reason that the rules of IUPAC nomenclature that we have did, that was very much necessary, so as to give this as the nomenclature for the structure. Very much simple and very much necessary. So now let us move on to the next one that we have. So this is the structure that we have, and we have to give the IUPAC name for this structure, and let us follow the first rule. And the first rule says that we should select the longest continuous chain of carbon atoms that are present in an alkane in this case, because this is the what we are doing for alkane, and for alkane it has some rules and we are following that. So we'll choose the longest chain that contains the carbon atom. So suppose if we choose usually that we choose from left to right, or we think that it would be the straight one. So let us think that first, and let us move on to the another one, whether we could see more number of carbon in a continuous chain or not. So suppose if I choose this one as a first carbon atom, so this is first, second, third, fourth, fifth, sixth, 7th, 8th and 9th. So therefore there are basically 9 carbon atoms that are being in a straight chain, in a continuous long chain. But is there any other option that I could see that there would be more than 9 carbon atoms in a continuous chain? in this molecule. Let us check that also. So if I suppose if I choose this one, that is 1, 2, 3, 4, 5, 6, 7, 8. So now 8 carbon atoms is very much less than the that we have observed earlier also, that is it was found to be 9. So in any case, suppose I could take this branch also, as you could see, that is this branch also, again it would be the 8 carbon atom if I choose this one, or if I start from this one also it would be the same. But let us choose this one and let us see whether it is 9 or not. By looking at itself, we know that it is not becoming 9, but let us count that also. 1, 2, 3, 4, 5, 6, 7, 8. Again in this position also I could see that the total number of carbon in a continuous long chain is 8. So therefore this one is not the correct one to give a sequence. So therefore what we are going to choose is we are going to select the longest chain, and that is been found to be this one. So now this is what we have choose, that the 9 carbon atoms are in a continuous long chain according to the IUPAC rule. So now the thing is we have to give the number to the substituents. And what are the substituents that are being attached? The substituents that are being attached is basically CH3, that is the methyl group, and one again substituent is also been attached is what we see here. So this is a substituent that where we see, and this substituent is basically a branched chain substituent, as we could see that this side chain consists of a branch. So therefore what we are going to do is we are going to name this thing also, and how to name this. So first of all, the thing that we have learned in IUPAC nomenclature, that the side substituent or the side chain that has been attached to the main parent atom, chain, and in this thing that the substituent in which the carbon that has been attached to the main carbon atom of the parent chain, if you would consider that, because this carbon atom is the one which has been attached to the parent chain, as we could see here. So therefore this carbon atom would be stated as 1, and then we'll move further and then we'll follow the IUPAC rule here also. So suppose if this is 1, so now this would be 2 and this would be 3, making this to be a long chain in the side chain. So making this to be a longest chain in the side chain. So now the naming of this would be, we will write over here just to make you understand that the naming of this substituent will be, as we could see, that it consists of first methyl and another methyl that has been present over here. So we'll name that first in the form of, that is 1, 2 dimethyl. So 1, 2 dimethyl, and the total number of carbon in a straight chain for the side chain is 1, 2, 3, that makes to be propane. But it is not propane, it is propyl. The reason behind it, that it is a substituent group. So therefore we'll name it as not propane, we'll name it as propyl. So this is the name of the substituent that we have. And now let us move on the further thing, that the other substituent that we have now in this case is basically methyl. So these are the two groups, but I have not yet numbered the substituents, or I have not specified the locants of the substituents. So for that we have to follow the IUPAC rule, and that is we have to start from that corner where the substituent gets, where we get more substituents or more branching. So, and that also very nearer to that from the end that we have started. So suppose if I choose from this corner, so therefore this is going to be the first, second, third, fourth, fifth. That means at fifth carbon atom I am getting a substituent. 6th, 7th, 8th. So 5th and 8th are the position or are the locants where I could see that the substituents are being present. So what if I choose from this side? That is, if this is first, then this one would be the second, third, fourth and fifth. So second comes first if I am talking about the locant. So second comes first and after fifth. So therefore this is happened to be the correct sequence to give the number. So therefore this one would be the first, second, third, fourth, fifth, sixth, seventh, eighth and ninth. So this is what we have. And now let us do it. Let us name this thing. So to name this thing, the first thing that we are going to do, we will choose this one because this is the bigger substituent, as we could see, and for that we know that this is the propane that we have, that is the propyl that we have, and in this case also what we are observing is methyl is also the present in here. That is the alphabetical order of methyl, it starts with M, while here also as we could see that it starts with M, that is methyl propyl. So the thing is, we will name this as first and the rest of then later. So for an example, suppose if I would say, or I would give the name directly, so name of this would be, because this group is been attached to the 5th position of the parent carbon atom, or the longest chain that we have chosen, so therefore this would be 5 here. We'll insert a bracket over here so as to differentiate that this is the group that has been attached to the 5th position. So therefore now this is a group that has been attached to the 5th position, and what is the group name? That is 1, 2, that is dimethyl propyl. So now this has been done, and let us move on to the next one that we have, that is methyl, and methyl is attached to the 2nd carbon atom, so therefore we will write it 2, and at 2nd position I could see methyl, so therefore 2 methyl, and the overall, as we could see, the parent carbon atom, or the parent chain, or the longest chain, that is containing 9 carbon atoms, and 9 carbon atoms, and moreover it is an alkane, so therefore this would be called as nonane. So this is the IUPAC name of this structure. So in this case we have followed every rule, and by that by this I have explained you that how to name this thing. So this will be better for you to understand that how could you name, and you could score more in your exams, and moreover you could understand that how to write or how to specify the names. So it would be very much easy for you. So now I have also few questions, so let us do that also, because it would be better that we will try to do every kind of IUPAC name of this kind, that we would get confused, or might we would get a bit doubt whether we have to take from numbering from this corner or that corner. So that would help you out. So that's the reason we have multiple questions that we are going to do, and we are going to give the IUPAC name for that also. So this is another one that I have, and we have to specify that. I think it would be very much easy for you to understand. So we have to select the longest chain. So let us see what would be the longest chain. So suppose if this 1st, 2nd, 3rd, 4th, 5th, 6th, 7th. So this is the one that we get 7, and you usually think that the straight chain would be the longest chain. But is that so necessary? Let us check that also. That is 1, 2, 3, 4, 5, 6. So this is found to be 6. So now in this case, basically, in this case, this is the longest chain containing 7 carbon atoms, and in this case we are not observing the branch, and moreover what we are observing is that, because the first rule is the one which is very mandatory, that is we have to choose a carbon atom, we have to choose a longest chain of carbon atoms. So that is the thing. And in this case also, suppose if I've moved from this side, if I moved and made the longest chain to be found to be 6, I could see that there are number of branches. I could see more number of branches, as in this case if I choose to be the longest chain, I could see only 2 branches, as you could see. But if I have choose this one, then I could have got 3 branches, that is 1, 2, 3, 4. 4 branches we have got. But that doesn't follow the first rule of IUPAC, that is select the longest chain of the carbon atom, continuous chain of carbon atom. So therefore the first rule is very mandatory to use that. And now we could make a decision to give the substituent their locations or their numbers. So if I start from this side, that is from right side, 1, 2, 3, 4, this would have been the 4th one, and this one would have been the 5th locate. But what if I started from left to right? So this one would be the 1st, 2nd, this one would be the 3rd and 4th. So anyhow this one has got the 4th position, but moreover what we could see is that if I move from left to right, then I could see that at the 3rd position I get a substituent, so which is better than compared to that of the earlier one that we have got as 4, 5. So we are choosing the number from this side, that is this one would be the 1st, 2nd, 3rd, 4th, 5th, 6th, 7th. And now what we are going to do? Yes, as you could see that there are two substituents. One is methyl group, so I will write it over here just for an instant that I should not get confused. And one group is also been attached here, that is this one. But this is a side chain, and moreover we could see that it contains branch. For that, what we are going to do? We are going to number this one. So let us number this one to be the first carbon atom. Why? Because according to IUPAC that we have got to know that the side chain, suppose if it is attached to the parent chain and the carbon atom that has been connected of the side chain that has been connected to the parent hydrocarbon, so that would be considered to be the first number. We'll give them it the first number. So now according to that we have got this to be the second number. So if I name this thing that the IUPAC name for this thing, then what would be the name of this one? Now the name of this one would be basically, because in first carbon atom basically two methyl groups are been attached, so therefore this one would be 1,1 dimethyl, and then again I could see that the overall carbon atom that are present in straight chain in this case is 2, so that one would be ethyl. So this is the name of the substituent over here, and this is the methyl group that we have. Sorry Nagesh sir, actually खांसी हो गई. Continuation. So the name of this one would be what? It would be very much simple to understand that we'll name this to be the first one, because this is the biggest group also, and moreover we could see that it starts with N, because we will not consider the di, tri or anyone. These prefixes are not being considered in IUPAC in sequence of giving the names. So only the alphabetical alphabets of the alkyl groups are to be considered. So therefore this is the methyl that starts with M, and this is again a methyl, but it is a smaller group. So we'll name the branch one, that is the side chain, to be the first preference. So for that we have got 4, and I could see on 4th position I could see this group is been attached. So therefore 1,1, that is dimethyl ethyl, bracket close, and on this thing I could see that at 3rd position I could see the methyl group. So therefore this one would be 3 methyl, and the total number of carbon in a straight chain, in a continuous straight chain, is found to be 7. And 7 when it comes to the hydrocarbon, moreover we could say for alkane. So therefore for alkane, 7 carbon atom is known as basically heptane. So therefore we could write it as heptane. So this is the IUPAC name of this structure. Very easy to understand. Let us do the next one. Suppose this is what we have, and we have to name this one. So how can we name? Yes, we have to choose the longest chain first. So this is what we have did earlier also, but it would be very much easy for you to understand. So suppose if I am choosing this to be the first carbon atom, 1, 2, 3, 4, 5. So 5 chains are in a straight chain. But what if I choose another direction, like this one? 1, 2, 3, 4, 5, 6. So in this case I get more numbers, so therefore this one would be my longest chain. And now we should have to give the number to this thing. So how can we give the number to this one? So we have to select such a way, we have to number in such a way that the substituents get the lowest number. So suppose if I choose from this one, that is 1, 2, 3, so I would get a substituent, or I could get a locate at 3 and 4. 5th, 6th don't have. But what if I choose from this side? Again 1, 2, 3, 4, 5th, 6th don't have. So means in any way if I go, I would find the same substituent, that is the same number. The locate would be the same, that is 3 and 4. So from which side should I choose? For that we have a rule. And the rule is this one. That is, if two different substituents, in this case the two different substituents are being matched, one is methyl and one is ethyl, are located at equivalent position from the two ends of the parent chain, the number of the carbon atom of the chain is done such that the substituent which comes first in alphabetical order should get the lowest number. So that means if I've chosen this one, that is if I choose this to be first, second, third, fourth, fifth, sixth, and I know methyl starts with the alphabet M, while ethyl, that is this group, it starts with E. So therefore that's the reason I have chosen this to be the longest chain, as well as the sequence of numbering should be from this side. Very much easy to understand, but this would be only possible if you know the IUPAC nomenclature rules. So for that I got to know that on third position ethyl group is present, so I would write this thing as 3-ethyl, and again on fourth position I could see that is methyl. So 3-ethyl, 4-methyl, and the overall carbon atom that are present in the straight chain is 6, and 6 number of carbon atom when it comes to the representation for an alkane is nothing known as hexane. So this is the IUPAC name of this structure. So now let us move on further also, and for further we have this structure. I think for you it would be very easy to understand that only three substituents are being present, and those might be C2H5, C2H5 again, C2H5. But is it true? We have to follow the IUPAC rule. See, the thing is, if you think that this one would be the straight chain, that is 1, 2, 3, 4, 5, then this method would be wrong. The reason behind that is because we have got C2H5 group, and C2H5 group is nothing known as ethyl, and that ethyl can be expanded in the form of CH2CH3. Here also it could be expanded as CH2Cl CH3. So now what we are going to do is we are going to write in a proper format. So this is the structural formula that they have provided to us, but they are provided a bit like a condensed formula. Just for the C2H5 they have merged it, and for that we have to expand just as to understand that what would be the longest chain in this structure when it comes to IUPAC. So let us do that also. So for that, the 12th numerical that we had, or the 12th structure that we had, it was consisting of CH3, CH, and the C2H5 can be expanded as CH2, CH3. Now again CH was present, and below that CH2, CH3 can be written. And moving on, we have got CH, and again C2H5 in the sense CH2, CH3, and again we have got CH3. So basically what we did is we have converted this structure into this one. So now if I had choose this to be my structure that is been provided to me, and if I have followed the IUPAC rule, or just in the case to understand that this one will be the longest chain. So if this is the longest chain, if I consider it to be, then the number of carbon atom in this case would be 1, 2, 3, 4, 5 in a longest chain, and this one would be the substituents. But what I choose this one, that is this one. The longest chain would be 1, 2, 3, 4, 5, 6, 7. This one has 7 carbon atoms as a continuous longest chain according to the IUPAC. So therefore this one would be the longest chain. And let us do the next thing, that is to number. So we'll number it by giving from that side where we could see that the substituents will get the less number. So I could see that this is basically a symmetrical molecule. So therefore what when it comes to branching, so the number would be starting from this one, or either you would start from this side also, no problem. So let us do from this also. So this would be the first, second, this carbon would be the third, fourth, fifth, sixth, and this is seventh. So there are basically 7 carbon atoms that we have shown in a straight chain, and moreover you could see that the substituents are being attached on third, are attached on fourth, and on fifth. But the substituent that is attached on the third is basically methyl. And again, the substituent which has been attached on the fourth position or the fourth position of carbon atom is basically known as ethyl. And here also I could see that methyl has been present. So the name, so the nomenclature of that of this would be what? It would be very easy to understand. And the IUPAC nomenclature of this would be, because at third position and fifth position I could see two methyl groups, and more important, methyl starts with the alphabet M while ethyl starts with E. So this will give us a preference to write the ethyl first, and then we'll move towards the next alphabet. Now we will name this structure to be, but before that let us see that what are the substituents that are being attached. So therefore at position number 3rd I could see methyl group is been attached, and at position number 5 again a methyl group is present, and moreover we can see that the methyl starts with M while the ethyl that is starts with E. So according to the IUPAC, that we know that we should write in an alphabetical order when it comes to the substituents. So the substituents are being arranged in such a manner that the according to the alphabetical order, the one which has the prior alphabetical will be the one which will have the prior alphabet will be written first and then later on. That is for methyl in this case. So therefore, because ethyl starts with E and ethyl is in position that is 4th position, so therefore we could write it as 4-ethyl. And on 3rd position and on 5th position I could see that there are methyl groups, so therefore in that case that is 3,5, and the methyl groups are being 2 methyl groups are being present, so therefore we could write it as dimethyl. And overall the straight chain, or we could say that the longest continuous chain, consists of basically 7 carbon atoms. And when 7 carbon atoms are in alkane, with respect to alkane, then 7 carbon atoms or 7 hydrocarbon atoms are basically known as heptane. So heptane is the hydrocarbon which contains 7 carbon atoms, so therefore we could write it as heptane. So this is the IUPAC name of the structure that we have did. So in this case we have been careful, that is if happened that if we have chosen a regular thing that we think that if this one would have been the C2H5, again this one would have been the C2H5, then the IUPAC name of this structure would have been like 2, 3, 4 triethyl pentane. But that would be the incorrect one, because that doesn't follow the IUPAC rule. And meanwhile the structure can be written, there is no problem, the structure can be written according to the name that we have decided, but to follow the IUPAC rule, that is the main thing. So according to the IUPAC rule that we have did, so this is the right method to write the name of this structure, and moreover we have expanded that condensed structure. So in this case we have got this one. So let us move on to the next one that we have. So that is this one. This is not a structural formula. First of all, this is not a structural formula, and moreover this is actually a condensed formula, and this is not even a molecular formula, because molecular formula indicates everything about a particular atom, how many number of atoms are being present in the overall molecule. But as we could see that this is the one which has a bit of thing that shows that this one would be basically an alkane. There is or might be an hydrocarbon, so therefore they have inserted a bracket, so therefore this is nothing but a condensed structure. So how to name this? We can't name it by looking at the condensed structure. So for that what we have to do, we have to make it in a structural formula. So let us make this to be the structural formula, but for that let me give you a hint that since this is the carbon atom, and so this one would be in the middle, so I would write this to be like this one. And moreover, see that one carbon atom consists of 4 valency, and so these are the 4 valencies of the carbon atom, and in that 4 valency basically C2H5 groups is been attached at each valency. So therefore I could write it as here as C2H5, here as C2H5, and here as C2H5, as well as here. So this is what I have converted the condensed formula into a structural formula, but this is not a complete structural formula, because I could see that here also we could see that C2H5 is present. So for a betterment, so as to give the IUPAC name, again the same thing that we will do that we have did in the structure 12, that is we have expanded the C2H5 into CH2 and CH3. So we'll expand this and let us see what would be the IUPAC structure for this one, and as well as the IUPAC name. So we could write the structure as, we have made the C2H5 to be written as CH2CH3. Here also that is CH2CH3. Meanwhile here also that is CH2CH3, basically known as ethyl group, and here also CH2CH3. So this is what we have made the condensed formula, and how to name this. But to name this, the first thing that we have to apply is to apply the first rule of IUPAC and for the nomenclature of alkane, that is select the continuous longest chain of carbon atoms. So in this case I could select anyone. So this one would be the continuous longest chain, or even this one would be the continuous longest chain. So for an instance, suppose if I choose this one, like, so this contains 5 carbon atoms, that is 1, 2, 3, 4, 5. And what if I have chosen this one, that is 1, 2, 3, 4, 5, again 5 carbon atoms. So anyway I could take anyone as the longest chain, and as long as continuous chain. And now the substituents are, yes, simple to understand, that is CH2 CH3 and CH2 CH3. These are the substituents, and this could be called as ethyl. Again this is an ethyl group, and the both are being present in such a position that they have got a minimum branching or sequence. The locate is a minimum. So like this is the first, second, third, fourth, fifth. So at third position the both are getting the same location. So it would be simple to understand or simple to write, that is it would be basically 3, 3, that is diethyl. The overall carbon atom that are present in the straight chain or the longest chain is 5, basically making this hydrocarbon to be called as pentane. That is, it is 3, 3 diethyl pentane. Very easy. So now let us move on to the next one, and let us do this one also. So again this is a condensed formula, and for which we have to convert this into a structural formula. So by not consuming too much of time, so let us do this thing, and how can we write the structural formula for this one. So for that I know that I could see that this CH and CH2C, these are present in a straight chain, or we don't have to compensate any kind of thing, and we don't have to apply any kind of strategy, because this is very much simple to understand that this one would be CH, CH2, C. But talking about this group, this carbon atom consists of 3 other methyl groups. That is, I could write this thing as CH3, CH3, CH3. But talking about this carbon group that has been attached over here, this consists of 2 C2H5 groups. So I could write it as C2H5, and here also I would write it as C2H5. But just for not making a confusion, what I will going to do is we are going to expand this also, and let us see what is the thing that we will get, or what this would be helping us to find out the IUPAC name of this. So let us do that also. So for that, what I am doing is I am making the C2H5 converted into CH3 CH2. So we'll get in this format, that is CH3 CH2 C, and again the C2H5 which was present above, that is this one can be written as CH2 CH3, and again the bond starts with CH2, then again C, methyl group. Again here also there is a methyl group, and here also there is a methyl group. So this is the structure that we have made for the structure number 14, and the thing that we have to do is, yes, we have to select the longest chain. So what would be the longest chain? Either 1, 2, 3, 4, 5, 6. Either this would be the longest chain, or 1, 2, 3, 4, 5, 6. Again this would be the longest chain. So anyhow the longest chain that we get the same thing, and moreover we could see that the locants would be also be considered to be the same. So therefore, for an instance, let me consider this to be the longest chain. So the thing is, next the thing that we have to do is we have to number this. So we'll number this as 1, 2, 3, 4, 5, 6. The reason behind that we have numbered from that is left to right, the reason behind that is the substituents here are more. So since the substituents here are being more, so that's the reason I have started the number from this side, and let us name this thing. So I could see that on position number 3 and position number 2, at position number 2 again methyl group has been present, and at position number 4 basically ethyl group is present. So I could have started the number from here also, but because ethyl group is a bigger group, so I could start from there, but that is not an IUPAC rule. The IUPAC rule indicates that the substituent should get the least number, and moreover we could see that the more the substituents are being obtained here, so that is the reason the preference was given from this side. And now let us name it. So for naming that, it would be very much easy that these are the methyl groups. Again, it starts with methyl, so I will write it as methyl, and it is basically ethyl. It starts with E. So the preference is very much simple, that is we should prefer the alphabetical order. So therefore ethyl is the one that comes first in alphabetical order, so therefore it has a position of 4, so 4 ethyl. And I could see that at second position and at second position again methyl group is present, so therefore 2, 2 times methyl group are present, so dimethyl. And the total number of carbon that are present in a continuous state chain, and we have chosen the parent hydrocarbon, and in this case we have found to be 6 carbon atoms that are present in this longest chain, continuous longest chain, that is making this to be called as hexane. So this is the name of the structure that we had. So now let us do the another one. So this is what I want to just explain, that we could do this kind of structures also, and we could name this kind of structure also. So let us choose the another one, and let us do for this. Now this one would be very much easy for you to understand. So let us try this out. So the first thing that we are going to do is, this is the thing that we could see that they are present as it is, and we could write it as CH2 CH. This is a condensed formula because it doesn't contain bond or it doesn't represent bond between the carbon and other carbon or hydrogen. So we could write this as this format also. And talking about this CH3 which is present 2 times, so I could write this as CH3, and this is been attached to this CH only. This whole has been attached to CH only. So therefore I would write in this format. And talking about this carbon is basically a tertiary carbon or basically a neo carbon atom, but moreover we could see that 3 CH3 groups are being attached to this carbon atom, making the structure to be this. So again the thing that we have to do is select the longest chain. So now it would be very much easy. I hope you have got to know more concept, that it would be very usual thing for you for now. So now this is the longest chain that we have chosen, and the numbering will start from, if I take the number from here, that is 1, this would have been the second, third and fourth. But what if I choose the number from here, that is 1, 2, that is second, third, fourth, again the same thing that I am getting. But which one to prefer? That yes, we have did in our rules of nomenclature in IUPAC nomenclature, that is we'll start the number from that end where the number of substituents is more and more branching starts. So therefore if I move from this that is left to right, I could see that the more branching I observe first, so therefore this is the prior thing that I have to take. So therefore the number would be 1, 2, 3, 4, 5. And on second position I see methyl group, and again on second position I see methyl group, and on fourth position also again I see methyl group. So the name of this would be very much easy, that is to write, that is on second and again on second and on fourth I could see methyl groups. So therefore this would be written in this format, that is 2, 2, 4. The methyl groups are present. How many methyl groups are present? 3 methyl groups are present. So therefore for that, trimethyl And the total number of carbon that are present in a straight chain, or we have chosen as to be called as a parent hydrocarbon, in this it is found to be 5 carbon atoms, or a 5 hydrocarbon atom. So the name of that would be basically pentane. So this is the answer for the structure that we have. I hope you have got to know. So these are the 15 structure that we have did, and this I think is very much sufficient for you to understand that how can we give the IUPAC name to the alkane that to the structural formula of an alkane that is being provided to us. Very easy to understand. So thank you friends for watching this video, and I hope you have understood this video. You'll share this video with your friends, and don't forget to subscribe eKita channel. Thank you.